What's up, peeps? There's three main things that I want to do tonight, right? I want to do a Leetcode problem. I kind of want to do another one if I can have the time. Mainly because the one that I'm going to do is one that I did last time, word search 2. I solved it on Leetcode, but I didn't solve it on Leetcode using the same code. Using the same code that I wrote. And in the Leetcode version, basically like 49 out of the 50 test cases pass, with one of them erroring on time limit exceeded. So I want to find out why, I want to figure that out, and then that's considered one question for today, but then, you know, I should make up for it to do another question. All right, we'll see how that goes. But I also want to finally work on the recipe manager. Find a recipe manager, self-host it, so that I can start putting some recipes on there for when I'm in Sydney. Okay. Beyond that, there's also, what was it? What was the other thing that I listed to do? Oh yeah, downloading lecture videos. So I also want to download my lecture videos, which should have just this semester's worth of studies. So 3 subjects worth of 12 weeks of lectures, all uploaded to my home server. All right, so let us first though do a monkey type. Ooh, no. No. Hello. Okay, well, I'm just going slow now. I feel like I can do that better. I'm gonna just do one more. Okay, well, this is also hard. It's testing my patience. This is gonna test my patience. Carrot. Carrot. Mm-hmm. Mm-hmm. Man, oh, okay. Okay, this one should be fine. Lovely, lovely, lovely. Okay. Hey, I'm speeding up. I'm speeding up. Without the syntax, more words, more word-based stuff, we can get pretty high word per minutes. Also, it's really bright on my screen. We're going to go dark mode. Let me quit this. So there could be some improvements to be made, which we will figure out when we look at the solution. Let's have a look.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve word search 2. And once again, like usual, this is a problem from the blind 75 Leetcode list, a list that we have been tracking on this spreadsheet, and the link will be in the description to this. And we are very close actually to being done with all the major problems on this list that I wanted to do. And probably at some point I will finish up some of these easy ones, like contains duplicates. I think that's a pretty trivial problem. Don't know how many people are waiting for a solution on that one, but I probably will do it eventually, just for the sake of completeness. So this is word search 2, and word search 1 actually we already solved on this channel, and that is Leetcode 79. So I do recommend understanding that problem before you try to do this one, because this is definitely an extension of that one. So we are given an...
Let me just double check what word search 1 is. Okay. Yeah. If any of the DFS is true, you return true. You add and you remove. And this is a backtracking problem, right? I mean, it's a graph and a backtracking problem. Would that be considered the case? Okay, so this is word search 2, but word search. This is solely using DFS. Given a 2D grid and the board in a string, return true if the word is in the grid, otherwise return false. Yeah, so given a word. But you might be given multiple words. And tree maze matrix DFS. Sure. Right. Our focus now is, go back.
M by N board exactly the same as we were in word search 1, and we are given a list of words this time. Previously, we were just given a single word, but in this case, we're given a list of words. And we want to know from that list of words, which of those words exist in this board, and whichever ones do exist, we want to return those words. So previously, we only wanted to know if one word existed in here or not. So we returned true or false. But in this case, we want to know how many or exactly which of these words do exist. So if we just reuse our solution from the first word search, what we're going to do is we're going to go to every single position in this grid, and we're going to start a depth first search recursively on here. So it's just backtracking, right? We're going to be checking brute force. What's every word we could come up with, right? So starting at O, could we come up with a word in our list of words, right? So we just go in all 4 directions basically, right? So if we go here, we'll get OE. If we go this way, we'll get OA, right? Et cetera, et cetera. We could, possibly make a word like this, OAAN. Or we could make a word like this, OATH, and this happens to be a word in our list of words. So we would say, okay, OATH, this is a word, so this is going to be added to our solution set, so it's going to go in the output. So a very brute force approach would be, so for every single word, we're going to run a depth first search starting at every single position and check, okay, could we make the word oath starting from here? Could we make the word oath starting from here, et cetera, until we get, all the way to the bottom of the grid. And we have run a depth first search on every single position. Now that's not going to be super efficient, right? And then we're going to have to do the exact same thing for the next word P, right? Because maybe this word could exist, so we'd have to brute force check every single position, et cetera, et cetera, et cetera.
Yeah.
And one way to analyze the time complexity of that would be something like worst case 4, and 4 because that's the number of directions, from any position we could go in 4 directions. Now we can't revisit the same position twice, of course. So basically the length of our depth first search is going to be the dimensions of the board. Let's call that M by N. Right, so that's how much one DFS would be, and we're going to be doing a DFS starting at every single position, so it's going to be something like M by N to the power, or M by N multiplied by 4 to the power of N, and we're going to be doing this for every single word. So basically, let's say W is the number of words, so this is going to be super inefficient. Now there is a way basically where we can make this more efficient, where we can get rid of this constant W. Basically, the solution is going to be, we're only going to have to run DFS starting from each position a single time, because as we're checking, what are all the words we can create starting at this position, right? Starting at this character A. What are all the words that we could create? Now, the main idea that we're going to be doing, instead of just checking a single word at a time, like running DFS on here just to check if this word exists, let's check simultaneously. Let's check all the words in our set, which of them can be created starting at this position. So that's the idea we're going to be using, and we're going to be using a data structure, which is going to be very useful for it, because what we're going to notice is we can check all words starting at here based on the prefix, right? So clearly here, we only want words starting with the letter A, right? So the prefix is going to be A. And what kind of data structure can help us organize these words based on their prefix? Guess what? Either you have heard of this data structure before, or you haven't. If you haven't heard of this data structure, then you probably don't have a chance of solving this problem in the optimal way. So I would learn what this data structure is first, but if you do already know it, the solution is actually not too bad to implement. So the data structure we're going to be using is a trie, aka a prefix tree, which is going to help us organize these words based on their prefixes. So let's say we had a pretty small grid and we had a pretty small list of words. The words are app, ape, and ace. So we want to know which of these words can be found inside of this grid. Now let's use the idea of prefixes that I mentioned. So let's say we're going to start our DFS here, right? So this is the first position we're going to be at, and we can't revisit this position twice. Makes sense so far. So far we have a single character, right? We have found the character A, right? So we want to know all the words that we could create starting at this position, DFS from here. And of course, then we're going to repeat that by doing a DFS from here, here, and here. But so far, we're only starting here. And of our entire list of words, we want to know which one of them have a prefix of A. Because if we had a word such as bat, then we'd say, okay, bat does not start with an A. So basically, we don't even have to consider that, right? We don't have to run a DFS on here searching for the word bat. It doesn't even exist in this position, right? The letter B does not start here. So what we're going to have to do is basically go through every single word. This word starts with an A. This word starts with an A. This word starts with an A. So potentially, so far, all of the words could be found starting at this position, right? So we haven't eliminated.
If, node end is equal to true. You're given a node. I suppose you could always start not from the root, but something else instead of the root. One indented in. Good evening, Rio. Welcome you to join. Seems to be that you are the first to at least text. We could go root I'm gonna just make an educated guess and say the child of odd minus odd of A and board of R C. I'm gonna make an educated guess here. In which case, so next node. Let me think this through. Nah. Alright, let's watch.
Any of these just yet. So now let's say we go down first, right? Of course, if we go up, that's out of bounds. So, we're just going to return there because we're going to see, okay, it ended with the word A. A does not exist in our list of words, so of course we're not going to do that. Of course, if we went left, that also would not work, but we can go down. So let's start going down first. So we add a P to our word so far. So far we have AP. So then again, we're going to have to just go through every single word, check, okay, does this start with AP? Yes. Does this start with AP? Yes. Does this start with AP? No. So we don't want to consider this word anymore, right? But as you can see, this is going to get kind of complicated, right? We're having to go through the list of words every single time. That's not really helping us out in terms of efficiency. A more intuitive way would be if we could check the prefixes of these words more easily. And of course, we know a data structure, prefix tree, is exactly what that is for. So basically what a prefix tree is going to be, it's going to be, every single character is going to be a node. So one node is going to be A.
Hello, Void.
We're just going to take these words and add them to our prefix tree. So we want all words starting with the character A to go here, right? So let's add childs of these. So what characters come after A? Of course, we have a P and then we have a C. So all words that start with AP are going to go down here, and all words that start with AC are going to go down here. And how many different words do we have that start with AP? We have app and we have ape. And all words that start with AC is just one word, ace. So do you see how this tree is organizing these words based on the prefixes? So now we started at A, right? We want all words that start at
What are you going to work on after doing Leetcode? I'm going to be doing I'm going to download my lecture slides. So that'd be, technically I could do this now, set it up now, and then it'd be doing in the background. There, should I do that? Let me finish watching this video and then I'll do that.
A. So this is where we're going to be at so far. And we see that, of course, there are 3 words that start with A. And by the way, let's say AP, this is not a word, even though it is a path in our try, because basically, let's just say we call these 3 leaf nodes happen to be the end of words. It's possible that we could have a word AP, but in this case, we don't up here, right? We don't have AP, so this node is not going to be marked as the end of a word. So only these 3 are marked as end of words. But so now when we go down in this direction, we go to a P, all we're going to do from this position is check, does this have a child P? If it does, we're going to say, okay, let's go there. So now this is going to be all words that potentially start with AP, so this prefix. Now, if we did not have a P, right, then we would say, okay, we went down here, AP, we don't have any words that start with AP, so in that case, we would just return. That's our base case, right? If we didn't have any words with a prefix of AP, which we could check pretty easily with this prefix tree, we wouldn't want to continue going down this direction. So you can see that we're making things a lot more efficient for us using this try. So now from P, we can't go down, that's out of bounds. We can't go left, we can't go up because we already visited that position. So we can go right, which is going to add the character E. So from here, from this P, we want to check, do we have a child E? Well, this is not the E, this is though, right? Okay, so far we did find a path in our prefix tree. Now let's check, is this the end of a word? Since it's marked purple, that's what I'm just indicating. So yes, this is the end of a word. Therefore, we found a single word down this path that we were maintaining called A, P, E, that yes, you can see it's found in our list of words. So therefore, we found one word that we can make from this grid that, can be found basically. So we're going to add ape to our results. Now from here, we would want to continue. Now we can't go right, we can't go down, we can't go left because we already visited there. So we would go up. So we'd say, okay, add a C, right? So from here, APE, and then we add a C. Does this word exist? Well, this does not have a child of C. So of course we can't do that. And that makes sense because this word APEC does not exist in our input list of words. So therefore, at this point, we would return because we don't even have any words that start with this prefix. So far we did find one word ape. Now, when we started here, the first direction we went was down, but it's possible we could also go right. So let's do that. So now we have AC. So we started here. We checked, does this have a child C? Yes, it does. It's over here, right? So now we can't go right. We can't go up. We can't go back left. So now we go down. ACE. Do we have a E child under this C? Yes, we do. And this is the end of a word, right? It exists in our list of input words. So now we found another word, ace, and then we would continue from our grid in the only position we can go to, which is the P, right? So we'd add a P. We'd say, okay, does this E have a child P? It does not, so therefore we can't continue. So that's going to be our base case, but it's okay because we at least found one word. So we can go ahead and add that to our list of words, ape and ace. So now is going to be the easy part. So we started our DFS from this position. Now let's start the DFS from C. So we look in our prefix tree. We do have a prefix starting at A. Do we have a prefix starting at C? We don't. So immediately we can say, okay, we know for sure none of our words start with the character C. We didn't have to run through the list of words to do that. We just did that in an O of 1 operation. We just checked.
Yes, sir.
Is our root node, does our root node have a child?
Sorry, that was
C?
cringe.
It does not, so therefore none of the words start with a C. So we don't even have to continue the DFS from this position. And you can tell that's the same is going to happen for the character E. None of the words start with E. We don't have an E root node in our prefix tree. Similarly, P, we don't have any root node P. None of the words start with P. So we're not going to find any additional words in this grid. We only found 2 words, ape and ace. We found ape and ace. We did not find app. So we're going to return these 2 words as a list. So once you kind of understand that this problem can be solved with a prefix tree, and you know how to implement a prefix tree, and you know how to implement backtracking DFS, which you've learned from word search 1, this problem is not too difficult. So now let's...
All right, so that's the same concept as what I've implemented here. However, what is the difference that causes one of my test cases to fail on Leetcode? Hello TT, welcome back, man. So 64 out of 65 test cases passed. It's just funny that one of them doesn't. I'm wondering if it's I have an idea, right? and that's going to be construct. I'm guessing construct, when you do an assignment like this, it's probably inefficient. So my guess is that the best way to make this better is to pop left. So pop construct dot append, and I'm thinking construct is a is equal to a list, and you don't need to specify non-local anymore, but you want to add yeah. So join okay, that should possibly do it. Okay. My output is not what I expected. What is up? I remember the name. Ready? Now why isn't this working though? My output is not what I expected. Let me undo some of this. Telling me this works. It doesn't. Okay. Yeah, okay. I changed something then. Let me go to my accepted solution, copy this one, and just paste it again. And then do those same changes. So instead of this, get rid of the non-local aspect. Construct is equal to, dot append board row column. Get rid of that. Now we add dot join construct, and yeah, construct dot pop. See. So look, that gives an accepted solution, but would this give an accepted solution here? Alright, this is the one using construct.pop. Ooh, okay, output limit exceeded is because I'm doing this. No, it's taking forever. Done. How? 63 63 out of 65. So it's almost, it's like, it's less efficient than even the previous solution that I had here. Right? 63 out of 65 versus a 64 out of 65, maybe, per se. Yeah, we're just gonna say, yeah, there is something that's making it not as efficient. Let's have a look now at some of the backtracking solutions. So, that's interesting. You're telling me this works as a backtracking. We're gonna just have a look. Okay, right, it shouldn't finish all of it because it's just backtracking, which makes sense. It doesn't pass all the test cases. But okay, sure. You can use backtracking if you wanted to. Rem is the number of rows, n is the number of columns, t is the maximum length of any word in the array words, and s is the sum of the lengths of all the words. And you can use a backtracking try and hash set. Add word. I didn't think of using add word. I really didn't think about that. And then you can do a backtracking try. Alright, well, let's look at the backtracking try plus hash set. I feel like this is what I did. Okay, and maybe that's suboptimal, right? Maybe that's why it's suboptimal, because you're using a hash set. So let me try running this. It's accepted. Okay. Not entirely what I was thinking. They do something different. Let's have a think why, or what the difference is. Just to make it somewhat the same as what we see here, I'm gonna go define add word as what they've done there. Current is equal to self. Yeah, I agree. Now, for scene word index, right, you use children as in, yeah. Is word true? Okay, so this is literally the same. For word in words, root dot add word of word. Yep. So I make a result set, exactly. Rows, columns, a visit set, exactly. And then we construct, I do a construct. But maybe that's not necessary. Interesting, they put the word directly in there and remove the need for construct. Could that perhaps be the difference maker? TT. And go ask you, Sam, David, can you prepare group Discord, YouTube? Is the Discord page, I want to join you every day. I see. I can roughly get what you're saying there. You want to join the Discord and maybe have a Discord call, maybe, so you can join actually. I don't know if we're going to do Discord calls yet, but it'll be at some point, maybe, in the future. I hope I understood your question, TT. Okay. Now, how the DFS is defined. Okay, that's different from how I defined it. I suppose that makes sense. You can define next node. I mean, that would just complicate things a bit. But yet again, like, why don't I just move this up? I guess I can. Which means this isn't necessary here. Is that right? Directions. Add the word. Hmm. If that's none, then you would return. Otherwise, you'd assert there is a next node. Okay. My thinking is then it must be that I have this extra overhead of construct. So this should ideally not work. So if I just run this, submit, I can submit and this should work. But if I go to word search here and try to run this, it shouldn't work until I make the optimization of removing the construct altogether. Yeah, we got time limit exceeded. So let's remove the construct altogether. I'm going to remove construct, put the word directly here. CI bracket, whoops. Damn. Word construct just doesn't exist anymore. Now the word has to be added to the actual part. Now it's order a column, right? It could be. And then we start with nothing. Construct is not defined. Where am I using it? Okay. Valid. Ooh. Wait. Fair. And you're telling me this would work. This would work. No, it doesn't. It's still a time limit exceeded. Give me a sec. What differs? I guess you're using a dictionary here. If you use a dictionary, versus using a 26. Could be. Discipline. Kasahara. Hello guys. It's 5 in the morning, up all night trading meme coin. Can't believe it, man. Oh man. That's why I'm not in it, because I don't want to stay up all night thinking about that. Literature review today. Okay. Sounds fair. Do that, Kasahara. Alright. Give me a sec, guys. Okay. All good, Discipline. Sleep well, man. Have a good morning. Yeah. Squeeze 1 Leetcode a day. That's what I hope too. When are you starting internship? It'll be in less than 2 weeks now. Probably like a week and a half from now. It really baffles me. What is causing this slight inefficiency? I have to know. I have to. What I'll try to do then is, since everything's abstracted in here, I think I can just try, using C. So C being the character. So if C is equal to none, now it's only none if no, that's fine. We're gonna say if C is none, if C not in this, then we create the trinode. Make the current equal to C, and then end. Okay, so that should be an optimization, perhaps. Wait, never mind. Okay, for sure. The way you interface with it is going to be different as well. Arg. CI braces. Oh, CI braces. No, it doesn't matter. Child of given Board row column. Key error. Oh yeah, right, it's not even done correctly here also. Ah, well, that's my bad. Damn, that's my bad. If board row column not in node child, return. Else next node is going to equal to board row column. All right, now equal. Okay, whoops. Now you don't return. You don't need to return anything. All right, run. That's good. All right, that works. Muckend, I would love to know your Obsidian workflow. I mean, what part of it do you want to know? Hello, Henry, once again. It's been a while, actually. I finished my exams now, so yippee. I went to a few like club events, got to know some new people. It's been pretty fun after uni. What MacBook do you have, by the way? Are you screen sharing it to a monitor or just using the MacBook? I was... yeah, so I am using a external display, yeah. I'm using external display, and I have a MacBook M1. And Kasahara, did I say that I'd be going to the EOX? Did I say I was going to an EOX party? I don't remember. Because it kind of freaks me out that you do know. Unless I did say it. To which case, that's just my bad for misremembering. Okay. Let me try running this. See if it's actually an optimization. Oh shit, Kasahara. I did not know you actually were from Ostevs. What's your actual name? Damn. Muckend, so how do you use it to track DSA problems? Taking notes for DSA, do you ever come back reading your notes? Yeah, so for me I do. Every now and then, come back to read my notes. The way I track DSA problems is just create a new note, usually. So right now, you know, this is the note that I'm working in. This is the word search to, or search for word. So I should maybe call this, is this search for word? So if it's search for word, is that what I got to search up? Give me a second. Word search, search for word. Yeah, I did. Okay. Search for word search. That's from word. This is an extension from search for, okay. So like usually I would just, you know, create a node for each Leetcode problem, write any insights that I have from this Leetcode problem. I tag them with specific concepts. So each of these have like, you know, this is using backtracking. It's also using DFS. So I would all tag them here as well. So if I ever wanted to come back to this in the future, I can. The thing is, I haven't really used it that much to search for all my notes, but it is possible. So look, like these are the only three, I guess, other notes that talk about tries, right? So that's a good way to keep track of it. And that's how I've been keeping track of it. This extra stuff I just left here because I hadn't finished this problem yet yesterday. And that's what I'm doing now. And I usually try to put in like the time complexity or space complexity. And then that would be it. As much note taking as I need. It's just any insights that I can grab, I would put here, beyond just the question solving. Anything new so all the insights which I think would be useful when I revisit this question, I would put here. And then when I put them here, it means like I'm allowed to read these questions next time. Read these notes next time before I even attempt the question. And so it's like a quick summary of, say, the Leetcode videos summarized in something that you can read in 5 seconds. So it's basically condensing like an 11-minute Leetcode video to, a less than a minute regurgitation of the concepts. And then that's how I think of it as valuable. And that's why I would do it in this way. That's how I do it. So Henry, do you struggle with learning in class outside of ones related to your career? For me, it's hard because I know I might never need to use it. Taking cybersecurity course, I see. Yeah. To be honest, like, I never really have such a big brain to think about, say, whether it's useful or not. Like, I mean it in the most positive way possible, right? Like, you have a logical brain to not need to remember something that you personally don't think you'll need in the future. For me, at least, like, anything that I learn, look, I'm going to be in it for, say, like 3 months, right? For that specific subject, I might be in it for 3 months. I might as well be interested somehow. And that's almost like for subjects that are really tough, that would be my copium. I would just try and convince myself that it is useful. And I'm dumb enough to believe it for myself, is what I'm saying. Right? So basically what I'm saying is like, I'm dumb enough to believe that I like it, to continue it for 3 months so I don't need to, have some sort of friction to learning the concept. You could say like that's even the case for cryptography and security, the subject which I took last semester. Because, like, same thing, it's cybersecurity. There's some interesting aspects to it. I mean, okay. Like, looking back, I still like cybersecurity as much as I did. But I guess, cryptography and security is more about the cryptography. So it's a subset of cybersecurity in general. And with that in mind, right, maybe I don't really care that much about the cryptography aspect of cybersecurity. And yet I convinced myself I did. And to be honest, like, thinking this way might even actually change the way you think about yourself. So maybe you gaslight yourself into believing that it's actually useful. Just be dumb enough to gaslight yourself. Oh shit. We've got a couple of people from OSDevs. I did not know that. We'll take it. We'll take it. Thank you for joining, guys. All right, well, look, that didn't even solve the efficiency. So it wasn't even related to the braces, which just confuses me even more, right? What is the underlying difference that is causing what we're seeing here? If I go back, to the previous code here, tries plus hash, this is what I used, basically. Like, yeah, this is what I used. I'm even thinking now, like, is it range? Am I using range too much? Do I need to have barriers like these? Ooh, Henry. Oh, you're going to, okay, 2 a.m. in Seattle. All right, fair enough. Good night, man. Love that you're in Seattle, where the Amazon base office is. It's tough for me to present that long and go in detail with subject that I might not use downline. Yeah, no. I can get that part too. Nah, go to bed. Sleep it off. Think about it. Maybe gaslight yourself into believing it's actually useful. Consider the options. To be honest, this problem is taking a lot longer than I would have liked. It's already 9:17, but we gotta figure it out. Right. That shouldn't even be any different up until maybe the DFS. So if I look at my DFS right now, look, if I fully just replaced the DFS from here to here, okay, and what we did was rearrange node here. Whoops. This might work. Might. And then I will be able to isolate exactly where that inefficiency is coming from. Right. Should have noticed that earlier. Visit is actually visited. Visited. Okay. Have a look. Submit. Wait, why do you put tags in your notes? Does Obsidian allow search by tags? Yes, it does. That's literally what I demonstrated before. And hello, D0. Welcome. If you just click graphs, right, it just pops up with all the notes which I've done graphs or stuff related to graphs. Oh man, it's still, I still missed another visit. Here we go. Yeah, I did. I really did. Visited. Let me just try running it from here. God damn it. Yes, for sure. It's the child and the children differences. Node children. Finally, hopefully. That's the last one. No. Try node. Is word, right, is word. Is word for me is end. I see you're going to start doing that for my Leetcode. Yes. think you should. Not supported between instances of trinode and int. Why? Why do we have so many issues? And where is this one? Let me think. Why is it in C though? You're currently doing literature review for work, but it's like 3rd year elec eng knowledge. I don't know what elec is though. Literature review though, for work especially. Damn man. What do you work as? If anything, like if there's like literature review in coding jobs, I'm gonna hate life. I wouldn't wish it upon my worst enemies. It's like med plus SWE. Okay. So there is like a smart research component to it, huh? Abhishek, first node, then row column, then word. Root row column, then word. Ah, yeah. No, yeah, fair. Thanks, man, actually. Man, I changed one thing and now I'm changing everything of this function. Thanks for noticing that, actually. Abhishek. Please be the last thing, please. Okay. Let me try this and see now, finally, if we can isolate the problem down to the DFS. Well, okay, it is isolated down to the DFS, so it is a problem within the DFS, which means then that the child that I had, okay, so I'm gonna copy this. I still want to keep it, not using a dictionary for trinodes. I want to use my I want to use these. Paste. Copy DFS. Whoops. Paste DFS. Okay. Run. Gosh damn it. Back cat. Output nothing. Why is there an output of nothing? Why? Why? Give me a sec. Let me think. Hold on. Hold on. Let me just delete that. Run this. That works. You add this and now it doesn't. When it should just be replaceable. Is it because the word? What's the problem? Man. Yo, standard output is just giving us nothing. Board row column. Is this not going to give us something? What? Node child. Oh, wait. Okay, to be honest, Abhishek, this problem that I'm trying to resolve here. Oh, right. It's because of the way I implemented. Yeah, look, the difference here is I've got to change more things. However, I got to check here. Darn, I got to check things differently. This is way too much. All right, this is way too much of the same problem. But we will persist. It's because I used a different data structure just now when I changed. I used a different underlying data structure within the try node. So I was using a hash table before to store all the children, but now I'm using a array representation. And using the array representation, you have to call these children differently. So that was the only difference. And yeah, look, like this is why like I should have just been happy with solving the problem at hard and saying we're good. But we persist. We're going to finish this. We're going to figure it out. Change in bracket. Ord of board row column minus ord of a. Anything else? Yes, I'm putting my brackets incorrectly. Now it should be fine. We'll see. None type has no attribute end. Yeah, it could be none. It could be none. Oh man, it could be none. How was that resolved? Hold on. Just not resolved. Is it a default dict? No. Oh, right. It's because this isn't really done correctly. Is equal to none. If this is equal to none, then you can't do that. Oh, I keep on making a mistake. Insert. Oh, okay, there we go. C++. Oh, I solved this problem here as you did. Same as you did. I used C++ when I solved this problem. I see. Sick. Yeah, I'm trying to get up to speed with the med stuff. Yeah, I see. I guess it makes sense. Literature review and med related stuff. Okay, so we submit. Please. Oh, I know this would work. Right? It does. It's just that I don't understand why my original DFS doesn't work. Is it because there is a for loop? I don't think that would be the case. Maybe it's because I use range. I would be so pissed if it was range. I wouldn't be that pissed. Range is less than 0, or C is less than 0, or R is greater than or equal to rows or C is greater than equal to cols. Okay, and D and, okay. We can try this. Oh. It does mean, so that was the submitted solution there. I want to delete this. Okay, and we can try this. It's med imaging. So the lit is for the imaging stuff. Yeah. That makes sense. Yeah, that's what I was thinking. Like the SWE stuff wouldn't be that more like conceptually intense. YHNCE. Yo, I'm currently in my first year. Do you recommend any second year subjects at Unimelb? Beyond the, like, I'm assuming you're in Bachelor's of Science studying computing and software systems as your major. With that assumption, you're probably going to be doing the cores of, if I remember correctly, algorithms and data structures. I don't remember the rest, but algorithms and data structures, like, that's a really good one if you're doing it. Right? Yeah. Unimel mentioned, let's fucking go. You're going to be doing that one. Like when you learn algorithms and data structures, oh shit, you can do either like design of algorithms or algorithms and data structures. You can do either, really, it doesn't matter. But I've heard that algorithms and data structures is taught slightly better. But it's kind of one of the core. So the core is either design of algorithms or algorithms and data structures. The only reason why you would do algorithms and data structures is if you want more practical or practice rather than theory. And I would, personally do more practice. I would like more practice. So I would do algorithms and data structures. And that's what I did. Yeah, but other subjects is interesting. OSD is like the mandatory. Yeah, that's right. Yeah. I'd rather do DOA just because it's Sem 1, yeah, design of algorithms. Fair enough. Yeah, so Kasahara might know it better than me now. It's been a while. What other subjects though? In your second year, you can still take like third year subjects if you really wanted to. So like the other subject that was in my mind was like declarative programming, like I know people don't really like the idea of learning hard subjects, but to me, I'm like tanking my wham because I've picked hard subjects. So I might as well continue. That's one thing, right? If you got nothing to lose, then pick hard subjects. And the only reason why, again, my wham was tanked in my bachelor's was because I did pure maths. So I did pure maths as my major originally, and then I switched. They still haven't released assignment 2 marks for that. Man, okay, interesting. Real interesting. The assignment was due 2 months ago. Damn. Yeah, okay, yeah, tanking your wham, right? So so look, like personally, if you don't care too much about your wham at this point, I'm not suggesting like bad advice. This could be bad advice. But if declarative programming is kind of interesting, like I would pick it and try it. And the thing is, like, you have to at some point in your life feel the wrath of declarative programming at some point. And the sooner you do it, the better. Personal belief. Could be mid. Okay, guys, I think anyway, that was the reason. That was cooked, man. That was the reason. You can't use range. It's inefficient. I mean, that makes sense logically, right? Instead of using 2 bounds, you're using all of the numbers between those. I should next time just stick with using bounds. If that's the case, then let me think about it. Bounds. You got everything excluding those upper bounds and the lower bounds of 0. Less than 0, greater than rows. Okay. All right. I can remember that. So, like, if it's anything that I learned from today's Leetcode problem, is that using range is not good for bound checks. Okay? It's not good for bound checks. Because, when you do range, when you're invoking the function range, you're returning a list that could be unbounded in length. Whereas a simple check of like 2 bounds is literally a constant space complexity, I suppose. Technically also time complexity, I guess. No, just space complexity. So it'll be space efficient if you just use bound checking as opposed to using range function in your bounds checking. Okay, I get it. So I'm gonna say then that is relevant in the boilerplate code. Actually, you may not want to do this. this was the problem that stopped me from solving search for word 2. Okay, nice. I'm happy with that. So okay, that's fine. So I'll watch the video, try to change the next node. I can't be fucked. I can't be fucked with that one. So I'm gonna just say that's good. We're not gonna bother anymore. I'll keep these. Like, it doesn't matter if it's here or not. If anything, it gives more context. This is now reflected in boilerplate code. Okay. So that's search for word done. Like I said earlier today that I was going to do another Leetcode problem. I might not. Ah, shit. Let me think. I could. I feel like I could. Dipper, you made notes just now. What do you mean? I mean, yeah, I did. Perhaps I will do one more Leetcode problem. Like I said I would. And then I can push off other stuff to do tomorrow. Let me just make sure things are fine here. Is this... Yeah, no, that's fine. I should actually close this. It's not really necessary. This was just me trying to update my blog. I have a blog as well, and I just updated the app that I'm using to run the blog. Can you show me again the graph notes, what you're using to make those kinds of notes? That helps in revision and shit. Oh, okay, yeah. So this is just my boilerplate code. This is like the main file where I got all the, I guess, the key boilerplate of each of the algorithms. And I just made this on the fly, you know, during so many Leetcode problems that I've done so far. Yeah, it's got all the depth first search, breadth first search, so searching algorithms, linked list ideas, so pretty simple linked list idea, heaps and their time complexities, some ideas of backtracking in the sense that you need subset append and subset pop, where you need append and pop from lists throughout the backtracking, what the try node looks like as a Python class, what considerations must be made for creating graphs. You know, you can have a list of directions created just like this, or you can have, you know, checking bounds with if R is in range. Now, if R is in range, like this is why this is simple, but it's also not very space efficient, because range of rows, this is going to be a list when it gets evaluated. So when it gets evaluated, this is a list of something, and you're checking if R is in that list. Which I don't know if it's a... I mean, it should be a constant operation, but still, space-wise, it's not optimal. Actually, is it? That's a good question. Is R in range? Sorry. What is the time complexity of in operator on list in Python. Damn. Damn. I actually didn't think that it'd be O(n). I actually overlooked that so hard. Okay, that makes sense. Use Markdown or any particular extension. This is all Markdown. The only difference is if you see the syntax highlighting, it's because I do ---- Python. Haha got on that a while back. Was time limit exceeded on a couple questions for that on lists? I see. Well, now we know. Now we know. Now we actually know. Let's fucking go. Not bad. I'm not mad, but I mean the problem was like I've seen Leetcode do a problem where he's done like if R is in range of cols, if R is in range of rows. I've seen him do it in a previous Leetcode question. And it's inefficient. God damn it. I trusted Leetcode. I still do. Hello, copy multi. Welcome, man. All right, but yeah, like the rest is pretty good. Dynamic programming, bottom-up approach to dynamic programming. To be honest, I haven't done dynamic programming I haven't done dynamic programming in a bit. So maybe that's what I've got to do tomorrow. Let me think. Okay. This is fine. This is fine. Except I want to understand the third backtracking approach where you use only a try. Now this looks a little longer, does it not? Ooh. Okay. You mark the value on the board so that if you see it again, you just don't process it. I'm a little sus of this. It seems a little more complex than I would really like. Is this what makes it exceptionally efficient though? Is this what makes it above on that second tier? Let's go back. And by second tier, I'll show you what I mean. Ritvik, what advice would you give to someone to get good in Leetcode? I graduate in a month. The general advice is to start early. Nah, that's actually a cop-out advice. Sorry, that's actually a cop-out advice. To get good, you kind of need to really just focus on the concepts, like not even about the code. And then if you ever get stuck on the code, like you're looking at the problem for 5 minutes, if you're stuck for 5 minutes after you've read the question, just look at the solution right away. And then, you know, after the 5 minutes, after you've actually tried, you know, if you're stuck for 5 minutes, that's when you look at the solutions. Now, you know, what defines stuck? It's when you can't code anymore, you can't think of a next step in your code. So it might be at the very beginning, you know, where you look at the question and you're like, okay, how do I even start? And then you think of that, how do you even start for 5 minutes? And then you're just going to give up. That's what you're going to do. You're going to give up and then look at the solution. All right, and here's the thing. Don't fall into the trap of spending too long on a question. For me at least, I'm spending too long on a question right now. I've spent an hour and a half looking at word search 2 because I wanted to solve, I wanted to really understand why I was getting an inefficient solution at the end. I figured it out. And it turned out to be, it's going to be a life lesson now, technically. Because I figured out you can't use range in your bounds checks, or else you're going to have this agony for an hour. So basically, yep, that's the moral of my story. Hopefully, that helps. How are you going? How are you doing? I'm doing good. I am miserable. Not that much. I'm not that miserable. After solving this question, at least. But welcome to my channel, your channel. Okay. This third part though, right, yeah. I was saying I wanted to see what it was like if we used this. And if we would be upon within the upper echelon. Oh, yeah, okay, we are. I understand why there's 2 peaks now. Okay. Understood. I understand. Am I going to bother understanding this? Probably not. But just know there is a better solution that requires no sets. I mean hash sets. Okay. We know there is a better solution which exists, but we're not going to bother doing it. I will update Alacrity now with the most recent code. Now I say Alacrity, but I mean my Leetcode repository. GG DG, sorry, DG, copy all that, paste all it, right, quit all, git add dot git commit, solved, refactored, learnt about why you don't, learnt about not using range. Okay. You remember word search and there was a very obscure optimization, but cut runtime by 10 times. Yeah. So I'm not going to bother with the optimization for now. But yeah, I tried looking at it a minute ago. I think I'm cooked enough for now. I'll look back at it later. If I will look back at it later, that means I should star it. And yeah, all right. So look, now it's 9:55. I might not get onto another question, but I will get onto downloading my videos, my lecture videos. Now, You might be asking, how would you download those lecture videos without being so tedious? Well, thankfully, I created my own video, which talks about how to download the Echo 360 videos. And it's on that blog. So, where is it? Downloading, mass downloading. Okay. We're gonna go to Alacrity. Gonna go into Dev. Bro's plugging the channel on his channel. Hey, I mean, look, I'm using my own tutorial to learn. You know? The plug was inevitable. Alright, so doesn't mean though, this is the website we go to. I might just have that open. Watch out. Alright. Yeah, there's aspects to this that I could remember or that I might not bother. Just copy what I have here. So Alacrity again. Clone Echo 360. Now we're gonna create a Python environment. And we're gonna activate it. .venv scripts source.venv bin activate pip install requirements.txt and we'll let that download. Okay. So have you done nqueens yet? Yes, I have. I actually did that problem. That is a backtracking problem, right? Yeah. I did that problem. Not bad, I will say. It's like, you know, you pick where you put the queen. So you kind of like choose putting the queen here or choose putting the queen here for each of the rows. I remember that to a vague extent. Not bad. Thank you for the reminder. But that problem was, I could not have thought of that, to be honest, when I first learned about it. Python Echo 360.py. I could be running like a malware script right now. Because I haven't checked up on the actual repository in a while. Man, I shouldn't say that. I shouldn't say that because, you know, I got a YouTube video on it as well. I'd be cooked if someone just put malware on the actual repository. Sudoku Solver is another fun hard that's tagged BT. What's BT? Unless you mean by the way. Sudoku Solver. Alright. I'll keep in mind if I come across that one. You don't need to download Echo 360 videos if you never. I mean, look, if I spent 3 years studying at the University of Melbourne and I don't learn anything from it, and maybe my children would want to learn free lectures online. Maybe I'll give it to my children. Is that breaching copyright? God damn it. I should have never said that. I mean, they're an extension of me. They would be. So, surely it's not in breach of copyright. Oh. Shannon, he does, doesn't he? I mean, he probably gets, you know, actual consent. At least I don't actually, like, share them. Yeah. So, you know what? Doesn't matter. Really doesn't matter. Alright. But, I gotta go to Echo 360. I gotta go to Echo 360. Echo 360. Damn. So bright. In my face. Let me turn down the brightness. Okay. Log in. You guys know my uni email now. Courses. Academic advising. I'm still surprised I have my lectures all the way from Comp 1001. Still visible, is what I'm saying. None of your results are out. Man, I don't even want to check mine. Not that I think that I did bad, but I don't want to think about it. I should check it though. Computer vision is out? Man. Alright. No worries. We'll check it all out later. As in offline. Alright, but let's see. Computer vision, this is one. AI planning for autonomy, this is another one. Cryptography and security, this is another one. Alright, these are the three. And computer vision. Go 360 home. I gotta save this to. Let's have a look. Using --Firefox. --alternative feeds. -O. Now the output is going to be where I'm going to put it. Since I have connections, BC, education, Unimelb. So 2024 S2. S1 we had each of these lectures. APA lectures, I could put it in that. Hello, aristocratic thinking. Welcome, man. Kasahara. Okay. I don't get how you guys do it when you guys just refresh, because I know another friend who does the same thing. Man, you guys are just like, you guys are funny. That's all I can say. I couldn't be bothered. we'll call this lecture videos. And we copy his path name. Paste. Anything else? No. All right. Now I just got to run this. Maybe I'll copy this whole thing first. Oh, okay, never mind. Let me close that. Okay. I could run this in tmux. I'm gonna run this in tmux. Tmux. All right, I've got to go in 10 minutes, but we'll start this before we end this. No selenium. Oh, right. Source.vnv bin activate. I think that might be working, maybe. Alternative feeds doesn't exist anymore. Perhaps. As a command line argument. Damn, I gotta probably update my shit. Well, I think we'll call it a day then. I'll figure this out tomorrow, you know? I'm fine with figuring it out tomorrow. Blocks, hello man, thanks for joining, but we're gonna call it a night. You did catch me just in time though. But alright guys, I think we'll call it a night. I didn't get to recipe management again. I wanted to create recipes for when I'm cooking in Sydney, but I didn't. That's okay, because we did spend a lot of time learning about stuff and debugging stuff. I'm fine with that. Okay, regardless, I think it's been a good day. Been a good night, I should say. So I'll see you guys tomorrow, most likely, or if not tomorrow, it'll be the day after. So yeah, appreciate you guys. Thank you for sticking along. Hopefully we can have more chats as well. All right, peace guys.